Hello, so right now we're going to go over the in-class worksheet I created for the Monday class. So let's get started. The expression evaluation. The first one, string.format, percentage of 4.3f. Remember there should be a double quotes here. So now what it means actually at this point is the 0.3f. 0.3f means I'm not going to round it to the third decimal points. The 4 in the front only means I'm going to reserve 4 spaces for this output. But since we have more than 4 spaces, it doesn't really have an effect for my output. This is there to confuse you mainly. So let's count 1, 2, 3, and 2 is the fourth decimal point. It doesn't round up, so we get rid of it. The output will be 1.235 as a string. Alright, so 9 divided by 5. Remember 9 and 5 are both integer, so this will be an integer division. So the first part will be 1. 3 divided by 0.5. And if one of the numbers is a double, the result will be a double. In this case, it will be 6.0 and becomes 1 plus 6.0. That's 7.0 as a double. Remember the 0.0 for decimal numbers. Alright, let's continue. 5 as an integer. New integer as a wrapper class. And when we add them together, it automatically unwraps. So it's just another 5. 5 plus 5 is 10 plus 2.1. Again, integer plus a double. Together it becomes a double. So the result is 12.1. And our data type will be a double. Alright, let's continue. 7L means 7 as a long. And now I'm casting 2.9f, which is float, to an int. So 2.9f cast to an int will be 2.0. Remember, not 2.0, just 2. So when we're casting to an int, it truncates the decimal points. It does not round up. Okay, so don't forget about that. So 7L plus 2, which is an integer, the result will be the larger data type, which is long in this case. So result will be 9 and long. Alright, remember the primitive types? Decimals. There's double and float. Non-decimals. There's long and short. Byte. So these are large memory size. Large mem size to low mem size. Alright, so let's continue. 5 plus plus, this is one tricky question. So if we do a plus plus here, this results into a equals a plus 1. So increments by 1. But if we do 5 plus plus, it results to 5 equals 5 plus 1, which is 5 equals 6, and that's a invalid syntax in Java. So although you're very tempted to write 6, this actually errors out. Alright, so let's move on. Test as a string literal dot equals test. So first question is, can I call a method on a string literal itself? The answer is yes. I don't necessarily have to call it on a variable. I can definitely call it on a string literal. So I can call equals, I can call char add, I can call substring, whatever you can think of. If you can call it on a string variable, you can call it on a string literal. So test and test, I'm using dot equals. So it compares the value, and these two are the same, so it'll be true. Remember the lowercase t in Boolean. Right? Again, test dot equals new string test, another way to instantiate a string object, but then again I'm comparing the value, so it doesn't matter in this case, so still true in Boolean. Right? So Patrick.substring2 plus Lucky.substring4. So this is a method. This is a question testing you if you know the method of substring. If I only have one index, that means I'm gonna start at that index and get the rest of the string itself. So if I count 0, 1, 2, I start from the t over here and I get all the rest. And Lucky substring.4, 0, 1, 2, 3, 4, I'll get the y. So together they become tricky as a string. right? So when we're talking about range in Java, the first is always going to be inclusive. The second part is always going to be exclusive. So if I say substring 1 and 5, in this case, index at 1 will be included, index at 5 will be excluded, right? Same thing as, for example, next int. What was I thinking? I lost my train of thought. All right, I'll come back to it when I remember. Anyway, let's continue. So popfizz.index of O, it looks for the string and look for the O. So 0 and 1. Index of O starts at 1, so this is integer of 1 plus 2.4, again, integer plus a double becomes a double. So now it's a 3.4 plus 6L. And decimal as a non-decimal together still is a decimal point. So plus 6, this will become 9.4 as a double, right? Remember, decimal points always take precedence over non-decimals. All right, let's go on to big O. So there are a few options of big O, and we want to fill in the blank for these operations. So adding to the front of a linked list, right? Remember, linked lists are a set of nodes, and I normally have a head over here. If I want to add to the front of a linked list, all I need to do is create a new node, make it point to my original head node, and change my head to point there. So 3 operations is always going to be only 3, no matter how long your list is. These 3 operations will add to the front of the linked list. So in this case, is all in. So adding to the front of array list, this starts to get tricky. Array list is just like array. Let's say I have 1, 2, 3, 4 in this case. When I add 0 to the head, the resulting array should look like 1, 2, 3, 4, 5, 0, 1, 2, 3, 4. In this case, I have to shift everything backward 1. So eventually, I have to go through the entire array and shift things back. And as you can see, the longer my array is, the more operations I need to perform. That if I have 10 objects in my list, I have to move 10 times to get a space in the front. So adding in the front of an array list is a cost of O of n, right? So adding to the back of a singular linked list without tail. We revisit linked list here. We want the head to be here, and we want to add to the end of the list. So essentially, we want to create a last node here and have it point there. But in order for that operation to complete, I have to get to the last node, right? So if I don't have a tail, I have to start from the head, traverse through the next node, traverse through the next node until I hit the last node, and then I create this link so I can create this new node, right? So I have to traverse through the entire linked list if I don't have a tail. So in this case, adding to the back of singular linked list without tail is O of n. Now, if I have a tail, that changes a lot of things. If I do have a tail, I immediately have access to the last index, so a last node, so I can create the link immediately, right? So adding to the back of linked list with tail will be an O of 1 operation. Right, adding to the back of the array list, 2, 3, 4, 5, 0, 1, 2, 3. If I want to add to the back of array list, we immediately know which index I should put it in based on my size. So if I know that I currently have a size of 4, if I want to add to the back of the array list, I know index of 4 is where I want to put it in. So I can get the location I want to put in by using the size variable in the array list implementation. So adding to the back of array list is O of 1 operation. All right, number 6, getting the data from index and linked list. So getting in data from linked list, again. So now you're given an index and you want to traverse that many times into a linked list. when we're talking about big O, normally we're talking about the worst case scenario. So you can imagine that if I'm getting an arbitrary index, you can always say that, oh, let's say we're getting the last index. So in this case, I have to traverse through the entire array to get to the specific index. There is no way I can pinpoint a index directly. In this case, will be O of n. Getting data from an index and array list is different. So if I have array list, I know exactly where each data is. So let's look at example over here. If I want to pinpoint the index at 1, I immediately know where to look for. If I want to pinpoint index at 3, I know again where to look for, because the data in my array list is a fixed memory, so I know where exactly to look for it. So getting data from array list is very fast, and that's what array list is good for. If you encounter a question like you want to get an item a lot, and you want to choose between a linked list or array list, the answer will be array list, because getting data from array list will be a constant time. Right? And let's move on. Number 8, removing from front in the linked list. So should be fairly straightforward in this case. If I want to remove the front, I simply move my head to point to the next node. And since this guy doesn't have anyone to pointing to it, it gets garbage collected. So now I've removed the head node. So 2 operations, no matter how long your list is. So constant timing. Removing from the front in the array list is similar to adding to the front. And if I have an array list 0, 1, 2, 3, 4, 5, and want to remove 0, eventually I have to shift everything forward, alright, and get rid of the last one. So now I'll have 1, 2, 3, 4, 5, with the last one being null. Alright, so because I have to shift a lot, the operation will be of n. Removing from back in the array list is the same as adding to the back of array list. I know which exact location I want to remove, and there will be no shifting involved. For example, I have 0, 1, 2, 3. I want to remove the back, which is the 3. I simply just set this guy to null, and I'm done. So constant operation. Removing from back in single linked list without tail. Around spaces. So let's go on here. If I want to remove this guy, the node I need to stop at is here, right? So, and then I want to get rid of this link. So if I don't have a tail, I start from head, traverse through the entire list until the node before the last one. So 2 from the bottom or from the back, and I set the next of this guy to null, and then this guy will be get rid of, right? So again, I have to start from head, get to the second from the last node, and set the next of that node to null. In this case, the big O will be O of n. Removing from back in a single linked list with tail. So let's see if tail actually help us in this case. Alright, so again, we want to get rid of this node, and we have a tail, and we have a head. Let's see, if we now have a tail, people are more likely to say O of constant operation, but let's see why that isn't the case. If we have a tail, and our next is pointing to null, the link we want to get rid of is this guy. But who has this link? The node before the last node. So the tail, since it's a single linked list, you can't go previous, so this is not allowed. So in order to access this node, the only option for us is start from the head, get next, and get next. So the tail actually does not help you at all. So with tail and without tail, both will be in operation. All right. So that's it for the big O. Get some water. Alright, let's go to multiple choice. Which one of the following is a reserved word in Java? Def is not, func is not, do is a reserved keyword. Remember your do while loop. Do something, and while a condition. Alright, so do and while are both keywords, so C. And Java is not. What is the most general object that you can throw in Java so the compiler checks whether you're handling it? So it says compiler checks for you. So the keyword we're looking for is the checked exceptions or check objects. Anyway, so if we look at the hierarchy, throwable, divergence to error, and exception. And exceptions has runtime exception. Alright, so runtime exceptions are unchecked. Exceptions are checked. Errors are unchecked. Throwable is checked. Alright, so in this case, the most general that we can go is throwable. Okay. Right? So which of the following is the correct declaration of int array? Int bracket bracket, that doesn't make sense. Int a bracket bracket. So this actually is a valid declaration. If you say int a bracket bracket or int bracket bracket a, these two are the same. Right? So two different declarations of an array. So be sure that you know both. So B. And new int, that's an instantiation of an array. So that's different than declaring. We ask with declaration. And this is array list and there's no E. Right? Which keyword is used to make concrete methods in an interface? So the answer you'll be looking for is a static or default. So if a method is static, it has to be concrete, and default is a keyword that if you input into the method header in interfaces, that makes this method concrete and you have to give it an implementation. And since there's no default, the answer we'll be looking for is static. All right, which of the following about overriding a method is not true, if any? So the parameter types must match, yes. The order of the parameter must match, yes. The return type must be covariant, yes. The access modifier must be the same or more restrictive. So this is the problem. Access modifier cannot be more restrictive. It has to be less restrictive. All right, what that means is if I have a parent class and let's say I have a method called public, let's say protected, protected void method 1, right, with some arbitrary implementation, and now I have a child class with, again, void method 1. Want to override this. The question is, what can I put for my access modifier? If I put private, I technically didn't override this method because now the child method 1 is not visible to any other objects except child itself. So the definition, the rule here is it can only be the same or more less restrictive. So we can put protected here or public here. All right, we cannot put private. The access modifier must be the same or less restrictive. So D. Which of following will not produce an error? Right. Before we start this question, remember the two rules. If we go from decimal to non-decimal, is not okay. Number 2, from large memory size to low memory size. This is also not okay. So with these two rules in mind, let's look at this number 6. Float f equals 3.999. 3.999 by default is a double. So double is a decimal point number and float is a decimal. So we look at the second rule. Large memory size, which is double, to low memory size, which is float, and that's not okay. So number 1, it creates an error. Number 2, long 55. So now the right hand side is long, the left hand side is short. Long has a bigger memory size of short. So again, the second rule does not apply. So B is wrong. So it looks at C. Now I convert the right hand side to a long, so now it's a 4. And I want to assign long to a double. That's non-decimal to decimal. So that's not in our rules. So number C is, oh, what the heck happened? Okay. C is fine. Okay, whatever. All right, number D, 765.345F, that's a float. float is a decimal number. So decimal to non-decimal, that's not okay. So D is wrong. Alright, which of the following defines a legal enumerate class? So you just have to know this by now. Public enum. Public enum, my class A. There you go. Alright, what is true of at override? It has no function except for documentation. That's not true. The compiler checks whether the method actually overrides. If it doesn't override, it will not compile. So it is required in order to override a method. It's optional. It gives a compile time error if the method it tags does not override method. Yeah, that's true. So C. Number 9. Assume that the code below compiles and run without issue. Which of the following accurately describes the code? So let's look at T. T has a static type of T. The dynamic type is a milk tea. And bubble tea is casting this object to a bubble tea and assigning to the variable T. So when we're looking at a T, the casting does not play an effect. It's just changing what the new milk tea, the static type of new milk tea is to bubble tea, and assigned to a variable T. That's a lot of T. So just imagine that the variable is like a box and the static type is like the label. Now what's actually inside this box is the milk tea. But now I just put this milk tea inside a box called T. Alright? So T is a reference to a milk tea object, yes. That is a bubble tea type at compile time. Again, if we look at the at compile time, it's the static type. Alright? So if we're looking for a static type of a variable, just look for what is declared as. Right, so we want to look for something that has a static type of T. So T is a reference to milk tea object that is a T type at compile time is correct. Alright, let's continue. Which of the following statements are true? Abstract class can inherit from non-abstract classes. That's true. Any abstract class you created is still object and inherits from a non-abstract class, which is object. Right? So number 2, abstract classes can contain non-abstract methods. That's true, but not the other way around. If it's non-abstract class, you cannot contain abstract methods. So abstract class can contain non-abstract method. That's fine. All subclasses, whether direct or indirect, of abstract class must override in all abstract methods from the superclass. That sounds true unless the subclass itself is also abstract. In that case, you don't have to override the abstract class, abstract methods. So number 3 is false. Interface are a type of abstract class. No, this doesn't make sense. So C. Alright, so let's move on. Use the code below to answer the following questions. Hash set string mango equals new hash set. Remember the rules for a set is it does not allow duplicates. So now I want to add mango with lowercase, mango with uppercase, mango with weird cases, and again mango with lowercase. So these two are the same, so this one does not play into effect. So how many elements can be added to the mango? A set, you can essentially add an unlimited number. It resizes on its own. The 5 over here is here again to confuse you. It means the array that's initialized to hold the hash set data is initialized to 5. But once it reaches more than 5 or gets too full, it automatically resizes. So you can add unlimited number of data into a set. 13 was the value of mango of size, so since we only actually added 3 different items, the answer would be A. Okay. Polymorphism, we went through this in class. Alright. So, coding exercise. In this exercise, we will code some linked list method. We will practice some methods using only recursion. Alright, so if we want to look at the size, actually, I realized I made kind of a mistake. I didn't include a constructor for the node, so I am gonna add it here. Public node t of t data. Alright, and data this dot data will equal to data. Alright, so that'll be it. So now if we want to look at the size using only recursion, the idea right now is for every node, if there is a next, then we want to add one, right? Or the other way we can do it is whether if I'm currently at a node that's not null, then I would return one. Otherwise, I will return 0. Right. So we want to start with a private helper. So private int size helper, and I want to take in a node. Right. Temp. Right. So in this case, I want to return the size helper of head. Right? So my base case for this recursive method is if the temp I'm currently at is null, which means I reach to the end of the list, right? I want to return 0. Right? Otherwise, I want to return 1 plus size help, and with temp dot next. Right? Remember, we only have a instance data. We don't have a method called getNext. Sometimes this happens during tests, so make sure you're familiar with doing both of them. So if we walk through our size method right here, if the temp is null, I want to return 0. Otherwise, I want to return 1 plus size help with temp.next. So I'm counting the point. You can assume like it's like a pointer to whichever node I'm currently at. So it starts with head, and I pass in my head to my size helper. In my head, because my head is not null, it will return 1 plus the size help of my next node, which gets to here, the second one. And because this is not null, I'll have 1 plus the next node, and it gets here, 1 plus the next node, and it gets here. And because this is null, this will give me 0, and I add back to 1, add back 1, and add back to head, and this will give me a size of 3, which is correct in this case, right? So using that, we want to see how to write a toString. The ideas is similar. So the tricky part over here is we want to have the brackets here, and we want to separate it by commas, right? So the trick here is called fencing. Fencing is when I want to have a fence, space, a fence, and space. A fence, the way to implement that is I want to put down the first fence, and then put a space, another fence for every iteration, right? So in this case, no matter how many times you iterate through, it will be a complete array. So let's start with, so we have to check if our head is null. So we can, here, let's do this. String, answer, we can start with the first fence, bracket, right? If head equals to null, then I'm done. How about we do this? If head is not null, then we can do something more interesting. If head is not null, I want to call toString help with the head, right? Or we have to apply that to the answer. Okay, smooth that a little bit. Right, and then we'll want to close this fence and return answer. Right, so now the tricky part is how do we write the recursive toString helper? So we write it here, private, we want to return a string, called toString help, that takes in a node, temp. Right, so again, if my temp is not null, I want to create a comma in the space with the data. Right, so start with the base case. If temp is null, which means I reached to the end of my list. I want to return just simply an empty string. Right? Otherwise, I want to return. So it's like currently I have, let's say I have the head. I want to put a comma first and then the data. So I want to put the comma first with a space plus temp dot get data, or temp dot, since we don't have methods, we just say temp dot data plus the rest of the string, so to string help with the next node, which is temp dot next. Right? Oh, I forgot one thing. So again, over here, I will need to append the first data first. So I want to say answer plus equal to head dot data. Alright, so now we're done. Recursion is just something that you have to keep practicing. It might be hard to think about the solution at first, but eventually it'll just start making sense. Just so, if you couldn't figure this out, just I would say just keep trying. Right? Eventually you're gonna get it. So use recursion or iteration and add the data to the back of the list. Assume size method is implemented correctly. So if we use the same trick, we want to start from the head and get to the next, and we want to stop when my next is not null. Or when my next is null. So now I can append that to my back of the list. So if when I'm doing recursion, I should have saved some space. Let's do the private helper first. Private, what should I return? Maybe we're not going to return anything in this case. So add back help. That takes in a node to keep track where we're iterating through. And we want to get a hold of the data. All right. So our base case is if my next node dot next is null, I know that we reached to the end of the node. So, and then I can do simply node dot next equals new node t and with the data inside. All right, so this is going to be my base case. Else, I want to just keep iterating through, so add back help with node dot next. Right? Since I'm not returning anything, I don't have to write any returns. Okay, so let's look at our primary method here. The only edge case we're facing right now is, let's say we start with an empty list. Empty list, that case, my head is null, and node.next over here will give me a null point exception, and we don't want that. So we want to handle that first. So if head equals to null, that means nothing is in there. I just want to make head equals new node t with the data. All right. So otherwise, I want to just call add back. No, actually, before we do that, we want to just simply return because we finished our operation. And otherwise, we want to do add back. What do we call it? Add back help with the head node, and we want to pass in the data. All right, so that's it. Together, now we have a recursive add back helper. All right, so let's continue. Write a program that checks whether a given string is palindrome using recursion. All right, so um, palindrome is when I read from the front and read from the back, they're resulting the same, like wow or lol. So I kind of made a mistake for making these different cases, but we'll adjust to that. So let's start with public. Um, because we return true or false, we have to call it boolean is pal. Alright, because I'm lazy. And I have a parameter called string str, and this is going to be our input. So let's say I have a, b, b, a. Our approach in this case is check these two if they're the same. If they're the same, I want to strip these off and then check these two. So the only two cases I have, the two base case I have is whether I'm left with one character or absolutely no character. Alright, so that's going to be our base case. So if str.length equals 0 or str.length equals to 1, right? In this case, I've reached the base case, and I know it's going to be true, right? Else is more the recursive part. Else, we want to first compare if the first and the last index is the same, right? So we want to first compare if str.char at 0 double equals, because it's a character or a char, we can use double equals on primitive types. Double equals str.char at the last index, which is str.length minus 1. Alright, if they're the same, I want to strip off the first and last character, and then I want to call isPal on it again. So if that's the case, I want to call return isPal with the str.substring, and I want to start at index at 1, and the character that I want to strip off the last character as well. So in that case will be str.length minus 1, right? So remember the second part is exclusive, so I will not include the last character. Right? So if that's the same, I want to return that. If they're not the same, I know that it's not palindrome, so I would just do return false. Alright? So I think that'll be it. Let me check. Yeah, I think that's it. Alright. Cool. Oh, well. Didn't write into the method. Lol. Make sure you don't do the same thing as I did in the actual test. Alright. So, on to the last question. Write a method that reverses a string using recursion or iteration. For example, if input is ABCD, the method should return DCBA. Alright, so our approach in this case, if we have ABCD, I want to get the last character and then call recursive function on these ABC. So ABC, I want to get the last character and recursive call AB, and now I have B, and then recurse this. So now I will have DCBA. So we want to read from the top to the bottom. All right. So let's move this away. So let's write this. So reverse string. I want to first get the last character. So char c equals str dot char at str dot length minus 1. So that's the last character, and then I want to so there the edge cases if str dot length is 0, I want just to say return empty string. Right? So char c equals str.char, that gives me the last character. And then I want to call the substring method. So string rest equals str.substring of 1, which is inclusive, and I want to get the rest. Oh no, how would I do this? No, I want to get the maybe cd, now I have d, I want to get everything here. So I want to start from 0 and do str dot length minus 1. So in this case, the index of d will not be included. Alright, so now I have the character and now I have the rest. So now I want to construct this reverse string, so I want to return the c right here we get should be the first that appears. So we want to say c plus reverse string with the rest of the strings. Alright, and then we're done, I think. Yeah, I think we're done. Cool. So that's the end of this worksheet. Hope you find this helpful. If you see any errors that I made, which is quite possible, please leave a comment or just email me and I'll answer you as soon as possible. So for those who don't know my email is ypeng@gautech.edu. Alright, so good luck on your studying and have a good night.